In this video, we will talk about researchers use laser technology to create real-life projections. So make sure to watch the full video. Hi guys! Welcome to a new video from RS Technology. Before we get started, make sure to subscribe to our channel. In the Star Wars universe, lightsabers, which are a sort of advanced laser technology, are how the Jedi battled their dark side Sith opponents. These incandescent swords look beautiful on screen, but of course, in reality, they're just special effects. In the original Star Wars trilogy, it was a physical effect, a rotating pole swathed in reflective tape. Only the colors were added in post-production. In later movies and trilogies, as the lightsaber duels grew more intense, actors used prop swords to ensure that the fighting looked real. The glowing effect and color was added in after the fact. The one thing that remains consistent throughout the history of lightsabers on screen in real-life productions is that much of the lightsaber visuals are a combination of practical and digital effects. But now, scientists have discovered a way to create real-life lightsaber effects that you can see with the naked eye, not just on a screen. In a study published in Scientific Reports, 2 researchers at Brigham Young University detail their findings on how to create a sort of digital holography, full-color virtual images in air. Their method is called Optical Trap Displays, OTS, and it uses laser technology to 3D print light displays onto air. What are optical trap displays? Wesley Rogers and Daniel Smalley, who pioneered optical trap displays, called it the Princess Leia project, and it had one simple goal. Our group has a mission to take the 3D displays of science fiction and make them real, Smalley said in a release. We have created a display that can do that. It isn't just lightsabers that Rogers and Smalley have created. The project's nickname comes from the famous Princess Leia hologram that R2-D2 displays at the beginning of the first movie, A New Hope. But what the BYU team is creating aren't simply images you can view from one perspective, like a traditional image projected onto a screen. While hologram and digital holography may be convenient words to use to describe these new images, they are not technically correct. These are actually volumetric images that you can walk around, see and interact with from any angle. Holograms can be 3-dimensional but are not viewable from every angle. How did researchers project light onto air? The simplest way to describe what Rogers and Smalley have done is to think of it like 3D printing light onto the air. Laser technology traps a single cellulose particle and heats it, which allows researchers to manipulate the particle. They can use mirrors to push and pull the cellulose to create the image they want people to see. Then, a separate laser comes in and projects red, blue, or green color onto the particle as it moves through space, making it visible to humans. According to Ars Technica, this technique is called photophoresis. Because of the limitations of human vision, if this particle moves fast enough, it appears to our eyes as a solid line. This display is like a 3D printer for light, Smalley said in the release. You're actually printing an object in space with these little particles. It's not exactly a real-life lightsaber. 2 Jedi couldn't fight a battle or harm each other with these optical trap displays. But people could absolutely see the real-life effects. What could this be used for? Optical trap displays could lay the foundation for an entirely new way of viewing and interacting with images. Current holographic technology requires so much processing power that it doesn't scale well. Unlike OTD, holograms are extremely computationally intensive, and their computational complexity scales rapidly with display size, the researchers said in their paper. In other words, larger holograms require vastly more processing power. This isn't a problem for OTD. If researchers can figure out how to scale optical trap displays using laser technology, it could be a new way to project limitless virtual 3D images onto air, a sort of holovect, as seen in the Star Trek franchise. They could create entire virtual worlds people could walk through and interact with, virtual reality, but without a bulky headset. It's the latest work from Smalley and his team of researchers who garnered national and international attention 3 years ago when they figured out how to draw screenless, free-floating objects in space. Called optical trap displays. They're created by trapping a single particle in the air with a laser beam, and then moving that particle around, leaving behind a laser-illuminated path that floats in midair, like a 3D printer for light. The research group's new project, funded by a National Science Foundation career grant, goes to the next level and produces simple animations in thin air. The development paves the way for an immersive experience where people can interact with holographic-like virtual objects that coexist in their immediate space. Most 3D displays require you to look at a screen, but our technology allows us to create images floating in space, and they're physical, not some mirage, Smalley said. This technology can make it possible to create vibrant animated content that orbits around or crawls on or explodes out of everyday physical objects. To demonstrate that principle, the team has created virtual stick figures that walk in thin air. They were able to demonstrate the interaction between their virtual images and humans by having a student place a finger in the middle of the volumetric display, and then film the same stick finger walking along and jumping off that finger. Smalley and Rogers detailed these and other recent breakthroughs in a new paper published in Nature Scientific Reports last month. The work overcomes a limiting factor to optical trap displays, wherein this technology lacks the ability to show virtual images. Smalley and Rogers show it is possible to simulate virtual images by employing a time-varying perspective projection backdrop. We can play some fancy tricks with motion parallax, and we can make the display look a lot bigger than it physically is, Rogers said. This methodology would allow us to create the illusion of a much deeper display up to theoretically an infinite-size display. What do you think of our video? Let me know in the comments section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go. Thank you for watching.